Hey everyone, welcome back to the channel where we break down maths questions the easy way. In previous videos we've covered questions involving the sine and cosine graphs. Now let's move on to tangent graphs. Tangent graphs look a little bit different, so let's go through some typical exam style questions together. We'll solve equations using the graph y equals tan theta and then apply it to a right angle triangle problem. Our first question that we can see on the screen asks us this: if tan x equals 1.4, what two values of x between 0 and 360 give the same result? The very first step would be to mark on the graph the equation that we're given, in this case y equals 1.4. Looking at the graph, the line y equals 1.4 crosses the curve twice. Our first solution is in between 0 and 90 degrees. And taking a look, we know it's less than 90 degrees. Our first solution, therefore, is around 54 degrees. So we'll call our first solution x1 at 54 degrees. We know this as it's just shorter than 2/3 of the way along the line. In an exam, don't worry if you're 1 or 2 degrees above or below, as they will accept a range of answers. Now, to find x2, or the second solution, we need to know a key property of the tangent graph, which is this. Tangent graphs repeat values every 180 degrees. And so if we know our first solution, we can add 180 degrees or subtract 180 degrees from it to obtain the second answer as needed. We can see here that our second solution should be greater than our first one. And so we need to add 180 degrees onto it. This gives x2 is equal to 180 plus 54. This gives us x2 is equal to 234 degrees. A good check is to see that it lies in the right region of the graph. And we can see here where I've dotted it in black that indeed it does lie just short of 270 degrees. And there we have it. This is how you'd find values which satisfy a line on a tan graph. Right, in our next question, we have a right angle triangle problem. We need an equation in terms of theta for the angle ABC. Remember that tan theta equals opposite side divided by adjacent side. It's the formula I've written on the screen. Here, the opposite side is equal to 25 centimetres and the adjacent side to the angle is 15 centimetres. This gives us tan theta is equal to 25 divided by 15. Or tan theta is approximately equal to 1.67. Note, in this question we want theta on its own, as the question asks for it in terms of theta. We must therefore use the inverse tan function to get theta on its own. This gives us theta is equal to tan to the minus 1, 25 over 15. Or you could write it in decimal form if that's what you prefer. But it's best to leave your answer exact where possible. Now we use for part B, the graph to estimate theta. Note that 25 divided by 15 is approximately 1.67, which I've written on the screen. So we're looking for a value where y equals 1.67 and crosses the curve. In a similar fashion to how we did for question 1, we'll draw the line on and then give an approximate angle. Also, a key point to note here is that the angle we're interested in is less than 90 degrees. And so we'll only look at the solution that's less than 90 degrees on the graph, but greater than 0 degrees. If we carry out a similar method to part A, we get an answer of theta is approximately equal to 59 degrees. And again, in an exam, they would accept a range of probably plus or minus 2 degrees, depending on how you've read your graph, but anything more than that would be too inaccurate. It uses a very similar method to part 1, and so these type of questions are quite common for sine, cos and tan graph questions. And there we have it. That's 2 GCSE style questions answered. To recap what knowledge we needed for this question, we needed to know that tangent graphs repeat every 180 degrees. Solving tan x equals a value gives 2 solutions in the range 0 to 360 degrees. And in right angled triangles, tan theta is equal to the opposite side over the adjacent side, which you can estimate straight from the graph. If this helped you feel more confident about tangent graphs, hit like, subscribe for more walkthroughs, and drop a comment below if there's a topic you'd like for me to cover next. You've got this. See you in the next video.